let's do this problem right here. The question is asking find the eigenvalues and the eigenvectors of the matrix. So first of all, let's see how we can find the eigenvalues. So to find the eigenvalues, we generally use the formula that's determinant of a minus lambda I equal to 0. So if you set this one and find from this one we can find the eigenvalue. So first of all, we have to know what is a. So a is this value and lambda multiplied by I is identity. So for 2 by 2 matrix, identity is going to be something like this. It's going to be 1 0 0 1. So when we multiply this one by lambda, it's going to become lambda 0 0 lambda. So this is my lambda I. So if I deduct this one from a, it's going to become something like determinant of, so these are the two corners the lambda values exist. Therefore 7 minus lambda, 3 minus 0, 3 minus 0, minus 1 minus lambda. So the only lambda is going to be up here because 3 minus 0 doesn't make any change. Therefore this is going to be 7 minus lambda and 3 minus 1 minus lambda. This is equal to 0. Now determinant is going to be AD minus BC for 2 by 2 matrix. So in this case AD is going to be 7 minus lambda, 7 minus lambda times minus 1 minus lambda. So multiplication of these two, and then BC is going to be 3 times 3, so this is going to be 9. And if I equalize to 0 and if I solve for this one, I can find the lambda values. So those are going to be eigenvalues. So let's see what we get. So if I multiply 7 by minus 1, I will get minus 7, and if I multiply 7 by minus lambda, it's going to be minus 7 lambda, and minus lambda times minus 1 is going to be plus lambda, and minus lambda times minus lambda is going to be plus lambda square. And here we are going to have minus sign, which is equal to 0. Now let's arrange this in a quadratic formula type. So it's going to be lambda square minus 7 lambda plus lambda is going to be minus 6 lambda, and minus 9 plus minus 7 is going to be minus 16. This is equal to 0. Now we have to factor this one. So we have to find a value. When we multiply, we have to get negative 16. When we add, we have to get negative 6. So minus 8 and plus 2 will work. So lambda square minus 8 lambda plus 2 lambda minus 16 is equal to 0. And if I take lambda common right here, it's going to be lambda minus 8. And if I take plus 2 common right here, it's going to be lambda minus 8 equal to 0. Now I can write it as lambda plus 2 lambda minus 8. And if I solve for this one, lambda comes out to be minus 2 and lambda comes out to be 8. So these are the two eigenvalues we get from these equations. So this is the answer for the first question. Now the second question is how to find the eigenvectors. So to find the eigenvectors, we have to do the null space for both of the eigenvalues we found. So first of all, let's see how we can do this. So I bring this equation, this is the pattern, right? Say 7 minus lambda, 3 minus 1 minus lambda. So now I set this one into null space, so it's going to be 0 0 right here. And if I first let's begin with the lambda minus 2. So when lambda is equal to minus 2, if I substitute here, it's going to be minus minus 2 and it will become plus 2. So it's going to be 7 plus 2, and here 3 minus 1 plus 2, and other side is going to be 0 0. And if I add them together, it will become 9 3 minus 1, and 9 3 plus 1. So this is plus 1 plus 1, right? Now if you see, it's like it's 3 time multiplication of this. So you can eliminate this one by the simple method is swapping. So 3 1 9 3, and if you multiply the first equation by negative 3 and add it to the second equation, it will become 0 0. So let's do that. So 3 1 0, and if we multiply the first equation by negative 3 and add it to the second equation, this will become 0 0 right here, and this is going to be 0. Therefore we can now create the equation. Now also we know there's one pivot right here, and the other side we don't have anything, like it means there's no pivot. That means this is my free variable. So free variable is going to be this, and let's do this equation. Now if you want to Gauss Jordan, it's same thing, like when you do the answer, that's going to be finally become as whatever you get it from Gauss Jordan. So let's do this. 3x plus y is equal to 0, now I have to write the x in terms of free variables. So this is going to be 3x is equal to minus y, and therefore x is going to be equal to minus y by 3. Therefore my eigenvector for when lambda equal to minus 2, that's what we are doing right now. So lambda is equal to minus 2, eigenvectors is going to be equal to minus y by 3. So this is my x, and y is going to be y because it's a free variable. So now we have to take the y command. It's going to be minus 1 by 3, and here it's going to be 1. And if I take span is going to be, when we take the span, we have to eliminate the y, because y mean infinitely many possibility of numbers. So we span mean we want the simplest form. So in this case, simplest form is going to be minus 1 by 3 comma 1. So this is my answer for the eigenvectors when lambda is equal to minus 2. But we have to find the eigenvectors when lambda is equal to 8 also. So when lambda is equal to 8, it's going to be the same equation right here. So it's going to be 7 minus, instead of lambda, I'm putting 8. So 7 minus 8, here is going to be 3, and here is going to be 3 minus 1 minus 8, and other side is going to be 0 0. So I continue on the other side. So if I calculate this one, it's 7 minus 8 is going to be 1, and the other side is going to be 3, and other side 0, and 3 here, and here is going to be 7 minus 8 is minus 1. This is 3, and this is going to be minus 9, and the other side is 0. And if you see, if you multiply the first equation by 3 and add it to the second equation, it will become 0 0. So let's do that. So minus 1 3 0, and if we multiply the first equation by 3 and add it to the second equation, 3r1 plus r2 is going to give me 0 0 right here. And from this one I can solve this equation. It's going to be minus x plus 3y is equal to 0. Therefore x is going to be equal to y. X is equal to 3y, and therefore my eigenvectors are going to be equal to 3y comma y, because y is the free variable, therefore it's going to be itself, and x is 3y, and 3y comma y. Now we have to take the y command. It's going to be 3 comma 1, and then if I write in terms of spans, I have to eliminate the y. It's going to be span of 3 comma 1. So these are the eigenvectors, and that's all it. We found the eigenvalues. These two are eigenvalues, and this is my one of the eigenvector, and when lambda is equal to minus 2, this is eigenvector when lambda is equal to 8. So lambda is equal to 8, yeah, lambda is equal to 8. This is the eigenvalue when lambda is equal to 8. So this is the final answer. I hope you guys liked this video. See you next time.